Hello, this is Balaji Ganesan from IBM Research. Today, I'll be presenting a work done jointly by IBM Research and IBM Data and AI Business Unit. This is towards infusing graph neural network models and explainability techniques into the various products of IBM Master Data Management portfolio. As you might be able to see from this slide, this is work done by a fairly large team. This includes members from both IBM Research and IBM Data and AI. The first problem that I would like to discuss today involves explainable link prediction. What do we mean by this is link prediction that many of you might be familiar with. Here we are using in the context of predicting links between people in the real world. So we can call these kind of graphs as property graphs where all the nodes belong to one particular type, like for example, people or organizations. This is different from knowledge graphs. And our task here is to predict if two people in the graph who are currently not linked in the input graph predict a link between them if based on their node representation and attributes, if the model thinks that they should be linked in the real world. So that is a typical problem that you might have encountered in the literature as well. Why this has become kind of more interesting in the enterprise or the kind of use cases that MDM has involves two things, right? One is the kind of scale and also the attributes and the kind of relationships that exist in the graph. And the second aspect is explainability. So when we present these kind of model predictions to the users of such systems, unless we kind of provide really good explanations which are understandable by non-technical users, people will be unable to trust the models or incorporate into their workflow. Right? So explaining the GNN model predictions is critical for the adaptation of these kind of techniques. So the way we have approached this is we know there are few what are called as subgraph explainability techniques from like academia. We call them as subgraph explanations because these models produce an explanation for a link in the form of a subgraph. The nodes and edges that were responsible for one link, they will be kind of highlighted, and the other less important nodes would be kind of grayed out. So this is a typical output from models like GNN Explainer, and then like few other models, Graph Mask or like kind of LRP and few other techniques. So while those models are still useful, in this work we kind of explored, can we use more kind of rule based or kind of easily interpretable techniques to augment the explanations. So we considered few techniques borrowed from information retrieval, structured data, and then like knowledge graphs in order to see if the explanations can be made better. So for example, the first technique on the top right here, anchors, comes from the structured data world. This is work done by Marco Rubio and others in the structured data world. And we asked whether such a work can be adopted for the predictions of graph neural network models. Here we have two people, Ellen DeGeneres and Heidi Montag. These are kind of entities in the TACRED dataset that is widely used in the academia. And the model seems to have predicted that these two nodes should be linked. Now, the explanation that we get from, say, anchors is like because of these other attributes, like for example, the age of the person, the place they live, the country of residence, using such features, we can say with some confidence, like say in this case it's 100%, but it can be any other accuracy level, whether these two entities should be linked in the real world. So that is one example of adapting a technique which is already quite popular in the structured data world and seeing whether it can be useful to explain graph neural networks as well. So that is one such approach. So the second approach could be using the path ranking approach, where we ask if there are paths between two nodes that we want to link, and can we rank those paths and hence explain whether these two nodes are linked in the real world or not. So this is again borrowing a technique which has been around for some time and applying it into the property graph context that we have. Now let me go to the next problem, which is very similar. Here we have entity matching, which is determining if two nodes in the graph belong to the same real world person. It can also be organization. So the example here is like, as you can see on the top left, there are two records for a person who appears to be the same person, like for as humans to kind of, if we just look at it. Now, uh, traditionally, these kind of problems have been solved using various master data management techniques. In particular, IBM's MDM portfolio uses what is called as a probabilistic matching engine, among other things, to determine if two people are in fact the same person in the real world. So we applied the same GNN models that we discussed in the link prediction context to this particular problem, along with the same kind of explainability techniques, and we found that these kind of actually can be adopted for this problem of finding whether two people in our records happen to be the same person in the real world. So this is like kind of a specialized form of link prediction where we are focusing more on the same as relationship in and not other kinds of relationships like spouse or parent, child, other kinds of relationships. So yeah, this is like kind of an extension of the link prediction world. Now, one of the kind of constraints that we have for this kind of research is we cannot do this research on customer data or on data which is kind of not in academic data sets. The examples that I showed were all from Tucker data set, which happen to be quite small data sets. So we have a number of projects, including one that is currently presented at CODS COMAD, which is around kind of identifying personal data entities, redacting them, and then like kind of imputing values. So these are some of the work that we are currently pursuing. For example, we are trying to use language models with constraints in order to generate data for our research. So this kind of leads us to few other research projects which I kind of wanted to highlight in this short talk. So, like as you can see, we have been quite busy in the past couple of years, publishing a number of works, both from students and from our team. So, if you want to learn more about them, please feel free to reach out to me and my colleagues here at CODS Comat, and I hope you have a really good conference ahead. Thank you.